Good morning students, I am Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. In this video class, I am going to teach you about finite automata model and definition of finite automata. So first of all, what is finite automata? Finite automata is a machine model in a theory of computation. You just think about this. It is one of the machine model. So upcoming units we are going to see about lots of machines like push down automata machine and Turing machine and finite automata types of machine, etc. Okay, so basic machine model is finite automata. So what is finite automata? The definition is control moves from one state to another in response to external input. That means control moves from one state to another based on some external input. If you want to understand this concept, we have to remember the real-time example as a on and off state of fan. Okay, so now let us assume I want to make the fan to off state. Now it is in on state. So what I will do is I will go nearby the switch and I will do an operation that is push. I will push the switch. So now the input is push. So what is the state? Current state is on state. So what is the goal state? It should be in a off state. Okay. So control moves from off state to on state or on state to off state based on external input push. Can you understand? Push. Okay. There are two types of finite automata. That is deterministic finite automata and non-deterministic finite automata. So deterministic and non-deterministic, there is a big topic. I will explain you in the next video class. First of all, the model of finite automata. So what is the model of finite automata? You just remember, this is the model of finite automata. Okay, I told you this is the basic machine model. So this is the basic machine model of the theory of computation concept, that is finite automata model. So you just think finite automata consists of input tape, reading head as well as finite control. This is nothing but algorithm. Okay, so this is the input head points to the first input of the input tape. Right, first input. So the input is placed, every input, that means one input is placed into the one cell. This is the cell. So input tape consists of number of cells, infinite number of cells. How many inputs we want to add? We can add all the inputs in the input tape. So this is infinite. Okay. So but every cell in the input tape consists of, that means holds only one input at a time. Right. Okay. So this is the finite control. It means algorithm. That means CPU. This is the main control. So this consists of state. Okay, so I will explain you what is state and what is the input in the upcoming slides. So first, initially finite automata reading head consists of, that means point to the first input symbol, that is A1. Right, this is the model of finite automata. So you may ask, what is the model? Model means you just assume every automobile industry, every car have some features like BMW car have most heavy features and some basic car like Shift, that car have some basic features. So every car have some features like some models. BMW car have airbags, etc. But the basic car car doesn't have any airbag. So likewise, this is the basic model. This consists of this structure. Okay, you just remember like this. Okay, and I told you, input tape, it is divided into number of cells, and each cell holds one input at a time. That is a very important point. And read head, that means it reads one symbol at a time and move ahead. That means the finite control, that means state, it reads one symbol at a time and moves right. Okay, so that we'll see the model. And finite control, it is like an CPU, depending on the current state and the input symbol, it moves, that means the state changes to another. Like, see, depending on the current state, that means here you have states, depending on the current state as well as the input symbol, it takes the decision that I will teach you. So this is the model. Okay, now finite automata can be represented by transition diagram. How to construct a transition diagram is, every vertices, that is called state. You see this example, this is the transition diagram. Okay, so this is a state, this round symbol, it is a state. So this is every vertices. We have two states, two vertices, two states. Okay, so every vertices in the transition diagram are state. And edges, this is the edge, q1 to q2, this is the edge, that is one arrow mark is there, no, that is the edge. So edges represent transition. Okay, remember this is the state, this circle is called the state. I told you, know, example, fan example. So now q1 is on state or off state, q2 is on state or off state. Now you assume q1 is off state and q2 is on state. So these are states. Okay, circle rounded by circle is a state, and this is transition, right? So you just remember this. Now let us see this, take this example. This double circle is called as goal state, that means accepting state, right? And the state which consists of one arrow, that is called as initial state, that means starting state. And I will explain you very clearly. You consider this is off state, off, and this is on state. I want to make the fan to off state to on state. So off state is a starting state and on state is a goal state. So goal state is represented by double circle. You remember this, don't forget, goal state is represented by double circle. If you have pen and paper, you can note it down. Starting state is represented by state which with one small arrow. Okay, this is a representation. And what is this? What is this arrow? This arrow and this arrow, this arrow, this arrow. This is a transition. Okay, that's what we are explaining here. If there is a transition from state q1 to q2, like q1 to q2, here we assume q0 to q1, there is a transition from q0 to q1. Here we have q1 to q2, input a, for example q1 to q2, here we want to write input a, then draw an edge from q1 to q2 with input a, that is the example. Okay, you have to write a here, right? So the initial state will be q0. I told you, know, initial state, circle with arrow, state with one small arrow. And final state is denoted by double circle. Okay, and I will ask you a question. What is this state? This state is initial state. Why I am saying this state is initial state? The state which consists of one arrow here. Okay, and what is the state? This is accepting state or ending state. How I am saying this is a goal state or accepting state or ending state? The state which consists of double circle, it is a goal state, right? And what is this? Transition. Q0, it reads 1 and goes to Q1. Like this we can represent. Like I told you, know, off state, on state. Off state, now fan, it read the push input and goes to on state. On state, now the fan, it goes to the push input, read the push input, goes to off state. Like this you can understand the basic finite automata model. Can you understand? Right. Now I told you, know, every machine have some parameter. Like that's what I given an example. Basic features car and high feature car. So every car have some parameter. Basic features car have some parameter like steering, engine, brake, etc. But highly features car have some another parameter like steering, engine, airbag, and some other options like self-control, etc. Okay, can you understand? So we are studying basic model, finite automata model. So it has some 5 parameter, like 5 tuples, will represent like tuples. It means 5 parameter. So if you have this 5 parameter, then only we can say finite automata, right? Just listen. I told this is a finite automata. So we will check. I told which one? This is the finite automata, and we will check whether these parameter the finite automata consist. Okay. So now you want to know capital Q. I told you, you just write, take a paper and pen. You can note it like this. Capital Q, that means it is a finite set of states, right? See this finite automata. Capital Q means it is a state. How many states are here? 2 states. What are they? Q0 and Q1. Then how many sets of states here? 2. That is Q0 and Q1. So capital Q represent Q0 and Q1. Can you understand? So capital Q is finite set of states. Okay. And sigma. What is sigma here? Finite set of symbols. Okay. So how many symbols we have? That means input we have 2 input. What are they? 0 and 1. So how many input we have? 2. So what is sigma here? 2. What are they? 0 and 1. Okay. What is capital Q? This Q0 and Q1. That is state. What is sigma? That is alphabet. That is input symbol. 0 and 1. That means finite set of symbols. Okay. Now delta, it is a transition function. Delta is represents a transition function. See how many delta we have. Transition function is delta of q0, that means state, comma input symbol. So that's what I told you. State, based on the current state and the input symbol, control decides where it want to go. See q0, it takes the input 1 and it is going q1, right? See again second delta transition, q0, it reads 0 and goes to q0. See again transition, q1, it reads 0 goes to q1, q1, it reads 1 goes to q0. This is the transition. Can you understand? Delta means transition, don't forget. And q0, q suffix 0, that is initial state. What is the initial state here? I told you q0, because state with one arrow. And f is the final state. What is the final state here? q1, because consists of double circle. So I will ask you a question, whether this 5 tuples having finite automata have this 5 tuples. That's the question is, whether finite automata have this 5 tuples. Yes, I told you this is a finite automata. We will check what is capital Q sets states. Whether this finite automata have state. Yes, what is the q0 and q1. What is sigma? Finite set of symbol. Whether this finite automata have symbol. Yes, how many symbol? 2. What are they? 0 and 1. Okay. And delta transition. Whether this finite automata have transition. Yes, what is that? q0, it reads 1 goes to q1. q0 reads 0 goes to q0. q1 reads 0 goes to q1. So it has transition. And q0 is the initial state. What is the initial state here? q0. F is the final state. What is the final state? q1. Can you understand? This is the basic model of finite automata. Thank you.